No, Devanjan, I cannot hear you. Maybe now. Hey, Rupesh, is it audible?
Hello?
Hello, yeah, now it's fine. How do
Oh,
Rupesh?
now it's fine.
Yeah.
Yeah, actually, I have an issue with the internet. So what I did, from my mobile, I have made hotspot, and from iPad, I am taking the class.
Okay. Sounds interesting. Okay. So, Rupesh, am I audible?
Yeah.
Okay. Let's get started.
So just record for me today. For me, it's not possible.
Okay, started then.
Okay.
Okay, last time we were seeing around notebook 1, right? So, notebook 20. Now let's see more. Okay, so last time we saw how do you, last time we saw how to calculate your mathematically linear regression, right? Y is equal to mx plus c. Okay, today, So today, what we'll try to do, last time we predicted this straight line, right? Which is predicted in equation.
Yes.
Now what we do, of course, I mean, you have a straight line. Now you can have various curvy lines as well, right? Okay. Your prediction can be, things like this, or, things like this. So there are a lot of possibilities. How do you represent a curvy line? You'll typically represent as, power of x square, power of x cube, similar to that, isn't it?
Yes.
Okay. So to do so, how do you do it? Okay, so you understood, right? You'll have to represent the entire data as power of 1, power of 2, all that. So let's see what I want to say now. Okay, suppose this is your house price. Okay, I just want to have one diagram. I don't know where it's missing. See this data. So did I show this last time?
No.
No, right? Yeah. So we have this house price here, as you can see. This is your house price. Okay, this is possible of value of theta 0 and theta 1, right? Okay, and this is the prediction, isn't it? So given a if you are using this as theta 0, this is theta 1. Okay, this is theta 0 and this is theta 1. For a particular x, it will predict this value. Right? For a particular x, it will predict this value. Now let's see. Okay, now let's see. Okay, so how do you represent this entire thing in the form of matrix? Okay, and then how you calculate the coefficient? Okay, so what we have here, see, this is your training data. Okay, this is your price of the house. You can see here, price of the house. Okay, then you have, this is one more data. Okay, you represent your training data like this. Okay, since you have only one dimension here, this is your coefficient theta 0, theta 1. Okay, and if you do a matrix multiplication, your resultant, this becomes the prediction of house of size this. When theta 0 is this, theta 1 is this. This becomes prediction of house of size this. When theta 0 is this, theta 1 is this. Clear? Okay, you understood why this 1 is required, because 1 into minus 40 plus 2104 into 0.25, that becomes the answer. This is y is equal to mx plus c, right?
Yeah.
Okay, so considering you have coefficients, you can coefficient and training data, you can calculate the price of the house. You can do the reverse as well. Suppose you have to find best value of theta 0, okay, and theta 1. Okay, you have to find the best value of theta 0, theta 1, where this is your training data, this is already obtained. So what do you do? Got it, right? So you have to find best value of theta 0, theta 1, for which this equation would be valid. Understood? That is what your machine learning algorithm using linear regression solves. You have to find the best value of theta 0, theta 1 when this is given,
Okay.
this is given. Okay,
So here intentionally we are doing this 1 1 1 1 to satisfy this.
absolutely, absolutely.
Okay.
Okay, now if you have understood this, I will build on top of this. Okay, suppose this is for where you have only x. Now suppose your equation has something 0.5 x square, right? Suppose you have this 0.5 x square. Now what will happen? Okay, so assume there is x square. Now what will happen? You need one more column here, because how many coefficients will be there? These are coefficients, right? How many coefficients will be there now?
3 code.
Exactly, 3 coefficients.
3.
Exactly. So the size of this will be 3. One more data will come
3.
here, right? Okay,
Yeah.
and in this case it will be 0.5. Okay, so now this is x square, right? What will happen to this guy? This is your x raised to the power 0.
Yes.
Okay, this is your x to the power 1. What will happen here now?
It will x square. X square.
Exactly. You'll write x square here. So it will be 2104 square, whatever is it, 1416 square, this guy. And if you do this, you will find this. Okay. So when you have, so when this is not present, you have this and this, you have to find this. Got it, right?
Understood. Yeah.
Okay, so this is what, so that is why it is linear regression. Doesn't matter what is the polynomial regression you're trying to calculate. As long as you have this, you can very well calculate this. Or as long as you have this and this, you can predict what is the best value of theta 0, theta 1, so that you are closest to whatever is expected. Fine.
Okay. Yeah.
Yes. Yeah.
Okay,
Yeah.
let's proceed further. Now what we want to do for the training data, right? Okay, let's see here. For the training data, what, suppose this is your data. Okay, if you have to predict a straight line, it would be you're predicting something like this. But if you have to predict a like curve which is like suiting the requirement more, okay, so you have to create a curvy, you have to have a x square polynomial curve, isn't it?
Yeah.
Okay, so what are the possible options? You can have a x curve, or for using degree 2, you can have a curve with degree 3. Okay, you can have a curve with degree 4, you can have a curve with degree 5, and so on, or to degree 40 or degree 100, right? You can definitely have it. Okay, so the point here to understand is,
Yeah.
okay, so the point here to understand it, okay, so you can have an equation like this, it becomes like this. Okay, you can have like this also. Achha, a question, suppose you have 12 points. Okay, how with what degree of curve will touch all the points? Tell me, what is the
Sorry.
point? Huh? Suppose you have 12 points here. What is the degree of this curve?
No, because it depends on where the points will be. Right. Like here, it
No,
is random.
absolutely not. You have a standard
11.
formula. Okay, it is number of points plus 1. That is the minimum, that is a, maximum number of, degree of polynomial you would need to touch all those points. Understood, right?
Okay. Okay.
Okay. So if you have 12 points, you can have
Okay,
maximum
so if n points, it will be
n plus 1 degree.
okay.
Okay, max. Okay,
Like that.
max. Of course, you can get a better case,
13.
right? 13, yeah. Okay, remember this, Q's. Okay, so you have 13 degree, but as you can see, if you are create, you have 13 degree. Okay, of course, great. But if you are having 13 degree, does it really help with your prediction? See, what is the
No.
cost for this? What is the training cost for this function, for this curve?
Some
Zero, isn't it?
is
Because it is the difference between the prediction and the cost, and the actual value is zero for each of the point. So the training cost is zero.
zero. Yes.
Okay.
Like this is ideal case.
No, this is actually
Okay.
not ideal case. This is
Okay,
a bad case.
okay,
Okay.
okay.
Okay, that is because, say, suppose you have this house. Your house is this square foot size, but do you really want to sell it at this price?
Okay.
No, right? So though, this is fitting all the data, this is case of overfitting. Okay, though, if you're fitting all the data, but your predictability of your data set, of your algorithm reduces, so that is a overfitting case. So rather than, curve which is touching all the point, we want a generalized curve which could predict our price. Okay, so what you do for that, you divide the entire data into two parts: training data and testing data.
Yeah, but last day what we did, that cost function should be minimal, or
Yeah, cost function still should be minimal. So that's what we'll see here. So
okay.
what will you do? You'll divide the data into two parts. See, if you, okay, so if you, so what will do, using this colored point, right? You'll be predicting the line, the training, the curve. Okay, the curve you'll be predicting. But after the prediction is done, if you want to validate how good is your curve, what will you do? You will try to test with untrained data, isn't it?
Yes. Yeah.
Yes, yes.
Okay, that is what you do before examinations. Whenever you want to test intelligence of a particular person, you give him books, you give him examples and all. But when you really want to test it out, you will give him something that he hasn't come across, right? That is what you do here.
Right.
Okay.
Yeah.
Okay, and that is what you will be doing here. That's what you're trying to do. Okay, now let's see. Now let's see, suppose you have this entire data set. This is your training error. Training error means whatever data was chosen for training, this is the error of it. This formula is fine, right? This is the actual price. There is the square footage. This is the predicted price. This is the actual price, and this is the predicted price. You are finding the difference and adding them up. This is your training error. Okay, so what will be the testing error? You'll do the same thing for testing data set, and this will be a testing error. Understood?
Yeah.
Okay, so testing error is actually a better better way to identify which model is good. So this is training error. As of when you increase the complexity, you will see the training error reduces and finally it touches zero for 12 points in 13th order. But test order, what will happen, because that is data for which your model is completely untrained for, it will dip till a point. After that, it will pick up.
Okay.
Okay, what will happen? So what will you do? You will identify that this is the best point, isn't it?
I didn't understand it. Can you explain it?
Huh?
Where I didn't understand. See, yesterday we have made one y equal to mx plus c equation, right?
Hmm.
There, what we passed is the training data, right?
Yeah,
Okay, and this testing data, where from this will?
yeah. So let's see this. So what you do now? See, we have y is equal to mx plus c. It's a linear case, right?
Yeah, it is linear
Then you
case.
have quadratic where x square. Then you have till 13th power.
Correct. Yeah.
Okay. So if you increase the degree of polynomial, you automatically see the training error becomes zero. Okay.
Yeah. Okay. Okay.
Okay, but that is not the real
Right.
sign for
Right.
best model, right? You
Yeah.
want
Right.
something which is generalized, which shows good output in real cases also. So for that, what you use your testing error.
Okay. Okay. So
Okay,
that will have a different data or what? What like?
absolutely, absolutely. That will have a different data.
Okay. What we get, I mean, in real world, what we get as a training data is a different and testing data is a different.
Yeah, right, right, right. Training data will be different and testing data will be different.
Okay. 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 Yeah.
Okay.
Understood.
Okay, cool, cool. Okay. So coming back to this, okay. So you understood how to calculate polynomial degree, also degree 2, degree 3. Hmm?
Mhm.
Okay.
Yeah, yeah,
Okay, so let's try to understand this. If you, hey guys, you forgot doing one thing. You remember that?
What is it?
yeah. That your website.
Yeah, yeah, yeah. You have to write reviews.
Yeah,
Both of
yeah.
you forgot,
Actually,
huh?
Really?
no, no,
But
no, no, no. Today, actually, I have given feedback to, like, there was a feedback form he have given. So
oh,
that is done. That is done. That I have given. But this one is left out.
okay, 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 sure.
I'll do. I'll do.
Yeah. Okay, let's see.
Yes.
Okay, so let's see this. First, remember we have to, for degree with polynomial 2 or 3, we have to, for the entire train data, right? We have to convert into x and x square and x cube, isn't it?
Correct. Yeah. Yeah.
Okay, so this is
Yeah.
a function that is a function that is present inside your scikit-learn library, sklearn dot preprocessing import polynomial features. Using this, right, what you're doing, you're creating a model, creating a transformer. This is known as transformers.
Okay.
Okay, because this is capable of transforming the data. So when you do fit transform, okay, what you're doing here, you are taking 2 and 3 and you're converting into, this is your training data. Okay, 2 into 2 raised power 0 into 2 raised power 1, 2 raised power 2, 2 raised power 3. 3 you're taking 3 raised power 0, 3 raised power 1, 3 raised power 2, 3 raised power 3.
Okay.
Okay,
Understood.
Hmm.
okay, so you have this data.
So this is for that equation y is equal to ax cube plus bx2 bx
Right.
square plus.
Right, right,
Okay.
right. So what you're trying to do, you're trying to find a polynomial with degree 3 using this. Okay.
With degree 3. Okay.
Okay. Let's see what happens further. Okay. So see this function that we are defining here. Okay. Using this function, and this takes two arguments. One is this degree 2 and this is star star kw args, that is keyword based arguments. So there is a concept of pipeline. Okay, there's a concept of pipeline in scikit-learn. This is one of the most important concept. So what you try to do in this pipeline, you try to create one transformer, one estimator. This is transformer, that is estimator. Okay, the output of transformers becomes input of estimator. Okay, what is the purpose of this transformer? You can see here, transform takes the data, changes data into some other format. Okay, say let's see what I mean by that. Okay, see here. Okay, see this function call here. This is the function that we are calling above, right? Polynomial regression. Okay, what you are doing here, you are passing degree. First time it is 1, next time it is 3, next time it is 5. So just as you, let's assume a case, you are passing a degree with 3 here. Okay, the degree is 3. Okay, so when you go up, what is the degree value that comes here? 3. It overrides 2, right? 3. So what does it return? It calls this polynomial features, whatever we saw there, with degree 3, right? It calls the polynomial features with degree 3.
Sorry, I think I didn't get this.
Hmm?
I didn't get this.
Okay, let me explain. Okay, let's see. Okay, this is very important to understand. Now, when you write this function polynomial regression, right? Okay, polynomial regression, this is the function name. Okay, and you pass here, see here it's a loop, right? So first time it will pass with 1, next time it will pass with 3, next time it will pass with 5, isn't it?
Okay. Yeah.
Okay, so let's take a middle case. Let's take a case of 3 when the degree is 3. Okay, so what happens? Degree is 3. So this get the polynomial regression function gets the polynomial regression function gets a degree 3. Okay, it comes here. So what is the value here? Degree 3. Okay, so it calls this object, and what will degree 3 return here? It will return a f, right? F object, which is capable of doing the transformation on the data to degree 3, right?
Okay.
Okay, so
To
what
degree
is
3? Yeah.
yeah, so this transform is capable of, given a particular x, okay, it can transform a data into this type of format, isn't it? The x can contain a lot of data, and it will convert that into this format. Fine.
Right. Yeah.
Okay, when 5 is coming from there, it will convert this into 5 columns, right? 6 columns rather. Okay, right, Rupesh?
Yeah.
Okay, so let's see, we are generating some data x here. Okay, some data, this is your x. Okay, so when you're doing a fit here, you're passing this x. So what happens? X is one data. Each data of x, right, gets converted into a 4 column or 6 column, depending on you're calling it with degree 3 or degree 5. Fine.
Yeah.
Okay, and that data is input. Your input to this transformer is x. Okay, your output is x with 4 columns, right, given 3, or x with 6 columns, right?
Yeah.
Okay, that is the output of this, isn't it?
Yes.
Okay,
3 for 4 and 5 for 6.
yeah, exactly. Okay, now remember the previous diagram that I was showing you. Okay, see this diagram that I was showing you. I was telling you that, suppose you have more per degree, you'll have data here like this, right? Okay, like for degree 3 you will have two more columns. For degree 5 you have 2 more columns, isn't it?
Yeah.
Okay.
Yeah.
So what does linear regression function does, given this data, okay, that is your x, and given y, okay, this is your y, okay, it will be finding coefficients for you, isn't it?
Okay.
Yeah.
Right, so given this x, you can see here, okay, and which is converted, or I would rather use the word transformed, okay, and using this y that you see here, what you're doing, you're predicting this